Aya, sawa.
Inarekwa.
Aya, good evening class.
Good evening, class.
Sir.
Good evening, sir.
Welcome to our
Good evening. Welcome to
electronics
our.
class. So before we start the class, I want to start by calling a register. So is Kelvin present?
Yes, present. Present.
Present.
Vivian,
Vivian. Present, sir. Present, sir.
Ruth,
Ruth.
Present.
Amon,
Amon. Present, sir.
Brian.
Present.
Okay, I can see we are full class. So I think we can start our today's class. So today we are going to learn about resistors, and the objectives for the learning outcomes for this session is to know the factors that affect the resistance of of a a conductor, and we are also going to learn about color coding. So what is a resistor in your understanding? Kelvin, what is a resistor in your own words?
Okay, a resistance is a component.
Okay, a resistance is a component which opposes the flow of current. Yes.
That's true. So a
That's right.
resistor opposes the flow of current in a circuit. So what are some of the factors that affect the resistance of a conductor? Anybody with an opinion? Vivian?
Mwalimu, let me try.
Length.
True.
True.
Ruth?
Temperature.
Yes,
We have
thank you, Amon.
resistivity.
Temperature, yes, resistivity, length, and we also have the cross-sectional area of that conductor. So for length, resistance is directly proportional to the length of a conductor. So the longer the length, the higher the resistance. And then resistance is inversely proportional to the cross-sectional area of a conductor. An increase in cross-sectional area results to a corresponding decrease in resistance of a conductor. And then we have resistivity. Resistivity depends on the type of material. And then we have temperature. So for good conductors of electricity, an increase in temperature results to a higher resistance, but for materials like carbon, that is semiconductors, an increase in temperature lowers the resistance. So next we go to color coding. So normally resistance usually have 4 bands or 5, but nowadays we even have resistors having 6 bands. But today I want us to focus on the resistance with 4 bands and 5 bands. So starting with 4 color band resistors, the first color is usually a number, and its number is shown in the table. As you can see, if you have black color, that represents number 0. If you have brown color, it represents number 1, red 2, and so on and so forth. So you can read more from the table. The second color is also a number. And then we have the third color. It's usually a multiplier, that is times 10 to power. If it's black, it's 10 to power 0, brown 10 to power 1, red power 2, orange power 3, yellow power 4, and so on and so forth. And then the fourth color represents the tolerance. So normally when the resistors are being manufactured, you cannot have an exact resistance. For instance, if I want a 1 kilo ohm resistor, of course there must be some tolerance. So the tolerances are usually in form of percentages as indicated on the table. So that is it. And then for 5 color band resistors, it's just the same thing like the 4 color band resistors, but for the 5 color resistors, the first color is a number, the second color a resistor, and again the third number is also the third color is also a number, and then the fourth color is the multiplier, the fifth color is the tolerance. So let's take an example. So assuming you have a 4 color band resistor with the first color being orange, second color being brown, third is blue, and the fourth one is silver. So the resistance of that resistor will be, so orange we have number 3, brown we have number 1, so that is 31, and then we have blue. Blue is the multiplier, so we have times 10 to power 6, and then silver represents tolerance, that is a plus or minus 10%. So your tolerance becomes 31 times 10 raised to power 6 plus or minus now 10% of that. So that is it. If it was a 5 color band resistor, then we would have the first 3 colors being represented by numbers. So class, have you understood the factors affecting resistance and also the how to use color bands to determine the the value of resistance of a resistor?
Yes.
Yes.
It's clear.
Very clear.
Very clear, Mwalimu.
That's good. So thank you so much for your participation in our class. I want to invite any questions or any comments. Any question? So silence means that everything is clearly understood. So have a nice evening. Thank you.
You too.
Thank you.
Thank you.
That marks the end of our class.